Hello, this is Muhammad Javed, Lecture Mathematics, International Maritime College. My today's video is on the solutions of exercises, page 388, which is related to the addition of waves with same frequencies. Before we get into the solutions, I would quickly recall you the trigonometric identities. Cosine of alpha plus beta equals to cosine of A, cosine of B minus sine of A, alpha and sine of beta. And when the angle, there is minus between the angles, so there will be plus between the two terms on the right side. Sine of alpha plus beta equals sine of alpha cos of beta, then cos of alpha and sine of beta. This is there are well established rules, identities, formulas in the trigonometry. Here is the exercise we are going to attempt. Question 1. Express 6 sine of 3t minus 7 cos of 3t. So two waves are given. This is sine wave and this is cosine wave. Okay, this is frequency, amplitude and 7 amplitude, and we are going to subtract these two waves, and we are asked to write our answer in this shape. So it means we are going to apply the first rule, and alpha is phase, which is supposed to be greater or equal to 0. So here is the question again. Well, this is given, so we take it 1 as we do on our notes. Okay, so I'm going to take my start from here. What we are going to prove. So A is written outside, and this is first rule which I have mentioned here. According to that rule, I write the right side in the square bracket. Then finishing this square bracket, this square bracket. So A is multiplied with first term and A is multiplied with second term. Then plugging in the frequency, angular frequency value, which is 3 here, and it was mentioned in the topic earlier with the same frequency as we are doing here. So omega was 3, and A we don't know, alpha we don't know, and we take its second equation. So now we are going to compare this last expression with the given one. So the given is actually 1, and now this is the new development. So if we look, the first term here, and we look at the second term and the second, they both got sine of 3t. So it means we can compare them. Similarly, here we got cos of 3t and cos of 3t is involved here. So we can compare them. Compare them means we will make them equal. So look, now if we see in both the comparison, the left side here is cot 3 sine 3t and right here sine 3t, cosine 3t and cosine 3t equals so my slide work, and we will be left with this. So it means sine of alpha angle equals minus 6 by A. Now amplitude has been always positive, so 6 is minus, so it means this is negative, less than 0. Even if you don't do it, we can see from here amplitude is always positive, so it means this is minus 6, or you can write here it is less than 0 for yourself. The same way amplitude is positive, so it means cosine is also negative. Okay, this negative status will be used later. Anyways, here this is equation 3, this equation 4. If we take square of minus 6 and if we take square of minus 7, we take them on the left side, then take square of the right side of the third, and then take square right of the, so the square of a will be a square, and the square of sine alpha will be, okay, so you can change, you can write anywhere because it's plus. Well, after addition, so minus 6 square is 36, 49, a square common from both the term on the right, you see both got a square, and we will be left with this, which is the first identity of trigonometry, equals 1. So a square is equal to 85, or now dividing third equation by fourth equation, the division will be conducted between the corresponding sides, so left sides, right side, and it gives us 10 value 6 by 7, which is positive, so 10 is positive, and we know here all trigonometric sine, cosine, tan, secant, cosecant all positive. Here sine is positive and its reciprocal cosecant is positive. Here tan positive and tan reciprocal cosecant will be positive, and here cos and its reciprocal secant will be positive. So we know from here that sine was negative, cosine was negative, and now tan is positive. So these two are negative. Here all positive, so this is not a situation. Here only here sine is positive, but this tells us it is wrong. Here cos is positive, here it suggests that it is not this quadrant, so it means this is third quadrant. Okay, so it suggests this is negative here, actually sine, and this also negative, and tan is positive, which is tan here, so it suggests that the angle is here. So this is our alpha. Okay, so very simple. This little angle, this angle in the third quadrant from here to here is actually tangent inverse of 6/7, and if you see from here to O dash axis, it is pi, so means 180, so pi is our alpha. The alpha will be third quadrant. Yes, I explained here. This is 10, so it's got 2 times escalation going, even so you don't need to repeat the video. This is 90, so this is our alpha or A. Okay, so now we are ready for finishing of this question. We started from A sine of omega t plus alpha, and this is the requirement. Now amplitude is in our hand, omega was given in the question, and alpha we just calculated here. So after plugging in this value, that will be our final. So A amplitude was this, sine of omega t, I think it was okay. I think it was cosine, if I could remember. Okay, so I think I'm doing mistake. This is cosine. We started from cosine. Okay, plugging in value, and this is alpha value. So this is what the question was asking. Question 2. This is the expression to be written in this shape. So it means we need to go for amplitude, angular frequency, and phase. So we will start from this identity, sine of A and minus sine of B. If you see the formula sheet again, I think it comes at number 4. Well, so when we do our work neat and clean on paper, so yeah, so this is our third formula with a little mistake here. It is the third, the last one, sine of. So let's see if mistake is repeated or removed. Oh my god. So it is all sine. It is all sine. Okay. And after this we'll plug in values of angular. Okay. because here angular frequency is 1, no number is given, so this is our omega. Omega is 1, so we placed here 1 for W. Then we'll go for comparing. Let me change. Here we got sine t in the first term, there sine t in the second term. So first term and the second term will be compared here. First term and here the second term. I have corrected here. Okay, so this is second term, which is this one, which has got cos of t and cos of t here in the first term. So this is a comparison. Then cutting the similar trigonometric ratios, and this will be amplitude is positive, so at mean sine is negative, amplitude is positive and there is no minus, so cos is plus, sine is negative, cos is plus. Okay, let's see solving them. So the square of -2 and the square of this side, the square of 6 and the square of the right side, and then adding them then plus them. So after plus -4 a square was common, went outside, factored out, then a 40 a square equals a square, so a is under the square root of 40, so a is come out. So out of three things, a is come out, omega was given. Now we are going to answer alpha phase. So this work I will explain next page, but keep remember sine is negative, sine is negative and cos is positive. After division, so tangent is coming negative, a cancel with a and there is minus, so now 10 is also negative. Now let's come to coordinate system. So 10 is negative, here all positive, here sine positive, cos positive and tan positive. So because of this it is rejected. Okay, because of this one is rejected, cos is positive and sine is negative, sine is negative, sine is not negative, sine is negative here. So it is here. Sine is positive, sine is negative, cos is positive. Sine negative, yes, it is negative here. Tan is negative, yes, tan is negative here. So it means this is tan inverse. It will come negative, but we have to make it positive because alpha is always positive. This should be the answer. Good. So this is our answer, starting from here all the way. This is our answer, and this angle in the fourth quadrant is tan inverse. So I think when we complete one rotation, which is 2 pi, and minus this small angle, which is tan inverse, this will be our alpha. So alpha is 2 pi. Okay, I'm doing right. So this is 5.96. So take care, tan alpha is always positive. Hence, this will be equal to, because this was the question, and it was required in a sine omega t minus alpha. So here it is alpha, omega is 1, and alpha is this. So we got our destination. Question 3. Omega given, and if we look at this time second identity will be used, a and cos of omega t minus alpha, which is second identity. So we start from here, okay, and expand it. So according to second identity, it will be equal to cos omega t and cos alpha plus, in this identity we have plus, and I am putting a bracket because this a should be written beside it, and now sine omega t and sine of alpha. So I think it's clear. Now bringing a inside with both the term, plug in omega value, comparing 1 and 2 expressions. Here we got cos of omega t in the first term, and here cos of 2t in the second term. So it is here. Then sine of omega t here in the first term and here in the second term, which are here. Now this cancellation, and oops, why sine 3t? This is sine 2t. Oh my god, here also 2t. Actually I am copying from previous slide, then make changes, so during changes I forget something. Okay, so 5 equals this, and so it suggests that sine is positive, and this suggests that cos is positive. So very easy case, all positive here. And then squaring, adding left sides and right side, factoring out a square, and inside the bracket this is 1, and a is 26 under the square root. Now we are going for division, dividing third expression by fourth expression, and so this gone, and sine by cosine is always tan. 5 divided by 1 is 5. That, yes, already we got to some conclusion that we are in the first quad, and alpha is always positive, so it started from here and this. Okay, so it is our direct answer if it is here. This is alpha. Okay, come on. And 1.3 calculate. Hence, yeah, A omega and now alpha.